So what I'm going to walk you through today is the start of the 3.5 pooling it together task. First of all, I want to remind you that this task is based off our work on the 3.4 task, which we did on Friday, November 17th. So if you go back and look at your work from the 3.4 task on the water park, this is directly related to that. So I'm going to walk you through a couple of things based off what we talked about on that 3.4 task, and then we're going to work through a few things together. So as we're going through this, it would be really helpful for you to have out that 3.4 task. So go ahead and take out your 3.4 task so you can refer back to it and refer back to the work that you guys did in your groups. I'm going to focus this a little bit better. All right, so as we're going through this, one of the things that we talked about and in second period that I should have probably had you guys do first period, so I apologize for not thinking of that in advance. But as we looked at the 3.4 task, remember A of X, you guys said represented the amount of water in Allie's pool at any given time. Okay? And through that task, based on the fact that you guys figured out that she started with 28,000 gallons and then it was draining at a rate of 1,400 gallons per minute, you guys came up with the equation 28,000 minus 1,400 x, where x represents our time in minutes. So we want to make sure that we label our graph. Our y-axis is labeled for us, but what wasn't labeled was our x-axis, so we want to make sure we do that as well. Then you guys also said that similarly, d of x is the amount of water in Dane's pool. And based off what you guys did on that Friday, you guys said that his pool started with a total of 24,000 gallons and drained at a rate of 1,000 gallons per minute. One of the other things that you guys talked about was, although they started with different amounts and they drained at different rates, there was a time where they had exactly the same amount of water in each pool. And that occurred at their intersection point. And you guys correctly identified that as happening at 10 minutes. They each had a total of 14,000 gallons in each pool. So remember that each of these has a specific value. So x represents our time and this represents our gallons. So at 10 minutes, each had 14,000. Now, mathematically, we could convert, and then I'm subtract 14,000, 8,000, so I get a 14,000 gallons remaining. But the big thing is we want to keep in mind that this means that each pool had 14,000 gallons in it at 10 minutes. So when we get to this new situation where we're talking about them combining their efforts to drain the pools and clean them, that G of X represents the total water in both pools. So it is a combination of Allie's and a combination of Dane's. And what we're doing is we're adding the total water in each pool. So one of the suggestions I made was that you may want to actually make a table to represent this, to help you figure out what this new graph is going to look like, which is what they're asking you to do on question number 2. So I made a suggestion of making a table that involves x. So at time 0, Allie's pool had 28,000 gallons. Dane's pool had 24,000 gallons. And asking us to do in this scenario, they would have had a total of 52,000 gallons. And I made the suggestion that you could figure that out for various amounts of time. But I also indicated that you probably want to focus on the idea of what is really happening at this 10-minute mark. So if they each have 14,000 gallons, then how many gallons do they have together? Well, that would mean they have a total of 28,000 gallons. So one of the things you want to think about on your graph is, first of all, make a scale that's appropriate to fit 52,000 gallons. But then the bigger idea that we're going to want to get to is, at what time is there no water left in both pools? Okay, and why does that time end up being what it is? So this is the big idea. We're headed toward the idea of, when I combine their efforts, how does that affect the ultimate outcome? So use this table. Use the idea that we are now focusing on the idea of combining their efforts, so focusing on that G of X column, but using the idea that I can figure out how much water is in each pool individually based on the work that we did in that 3.4 task by having each of these equations to help me. So you're really going to want to use this table to help you answer questions 2 through 7 on the back. That's my start up for you. I know this is about a 6.5 minute, 7-minute video. Hopefully this helps, and I will talk to you tomorrow. Make sure you post your questions for 2 through 7 and just do the ready. I changed the assignment to just be the ready, not the ready and the go. Thanks, guys. Have a good night. Hope this helps.